In this video, we're going to take a look at the reduction of a nitrile to give a primary amine. So nitriles have this general structure where you have a carbon-nitrogen triple bond, and although they may not look similar to your other carboxylic acid derivatives, it is still a carboxylic acid derivative, and that's because this carbon atom here of the nitrile is in the same oxidation state as all of your other carboxylic acid derivatives. And we can see that by the fact that it's a carbon with 3 bonds to an electronegative atom, just like your carboxylic acid derivatives. Okay, so this is a nitrile. And so what we're taking a quick look at this video is the reduction of a nitrile to give a primary amine. So what we're doing if we're reducing this, let's go ahead and draw the structure of the primary amine. So this would be the primary amine that you would get if you hydrogenated this nitrile. So hydrogenation, I just mentioned, that's one way that we can reduce a primary amine. So what we want to notice is that we have added hydrogen, 2 equivalents essentially, across the pi bond. So we have added, so we had the addition, let's say, of hydrogen across the pi bonds. And so that might sound familiar. We saw this sort of reaction with alkenes and alkynes as well. And we saw that as a hydrogenation. So you can do this using hydrogen gas. And then you typically need a metal catalyst. And so for the nitrile, this will be a little bit easier if you use a more reactive metal catalyst. And the one that we use is called Raney nickel, or one that can be used, I should say. So this is just a more reactive metal catalyst. Right, so more reactive than what? So what I'm really thinking about when I say this is that palladium on carbon that we typically use when we're doing the hydrogenation of an alkene or alkyne. So we're going to say this is more reactive than palladium on carbon. Okay, so let's just take a quick look at this. Let's draw an example. Let's just draw a nitrile. I don't know, I got a little carried away with my carbon chain there, but that's all right. So this is a nice long carbon chain, and so if we do this hydrogenation, drawing the product is pretty straightforward. We're not going to draw a mechanism for this, but to draw the product, we really just want to carefully count our carbons. So the key is recognizing that this right here is a carbon on your nitrile. So say 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I did get a little carried away with that, but that's okay. We're just going to draw an 8 carbon atom. So 1, 2, 3, 4, 5, 6, 7, 8, and then the bond to the NH2. And that would be the primary amine that this would give us. Okay, and there's not really a whole lot more to say about the reaction than that. The key, again, is just going back to very carefully counting your carbon atoms to make sure you don't miss any. So this is a great way to make a primary amine. And primary amines are not easily made by substitution because as soon as you make this as the nucleophile, it tends to react again with an alkyl halide. One more thing I do want to quickly point out is there's another set of conditions that we will encounter very soon in a later chapter that we could use. So you're adding hydrogen gas, that's one way to add hydrogen. You can also add hydrogen using a nucleophilic hydride reagent. And the one that will work for a nitrile is lithium aluminum hydride. So that is a hydride reducing agent. And then as a second step, you are going to quench this with either water or maybe a small amount of aqueous acid. So this is a reduction that you will see in a later chapter.